All right, so this is my last example. The function s of t equals t squared minus 7t plus 10 describes the motion of a particle along a line. Find the velocity of the function of the particle at any time t greater than or equal to 0. Well, v of t is going to equal your s prime of t because you're working with your derivative of your position function. So I've got 2t minus 7 for t greater than or equal to 0. For part B, we're to identify the time intervals in which the particle is moving in a positive direction. Well, my particle will be moving in a positive direction when my velocity was greater than 0. So I'm going to set my velocity equal to 0. So I have that 2t minus 7, and t equals 7 halves is my test point. Something's going to happen to the left, the right of 7 halves. But we're going to look at that velocity function, 2t minus 7. To the left, I might choose this 3, and I get a negative value. To the right, I might choose 4, I get a positive value. So, the particle moves in a positive direction on the interval 7 halves to infinity because v of t is greater than 0. This next problem, identify the intervals in which the particle is moving in a negative direction. Justify. Well, the particle is moving in a negative direction from, and we're just running from 0, so I'll say 0 to 7 halves because v of t is less than 0. And then D, at what time, identify the times at which the particle changes direction. Justify. T equals 7 halves because v of t changes from negative to positive at this t value. So now we're putting this into the context of velocity. Life is good.